Hello, this is Mohammad Yasir Arafat, and today we are going to discuss A Level Physics 9702. And in this video, we will be discussing our first topic of chapter number 1, that is kinematics of uniform circular motion. Here, first, we must know what is kinematics. Kinematics is the branch of physics that deals with the change in state of a body without reference of force. So that means in this particular topic we will be discussing only the characteristics of motion and how they are changing when an object acquires uniform circular motion. And end of this video, candidates should be able to describe or define the radian and the express angular displacement in radians and understand and use the concept of angular speed and recall and use angular speed is equal to 2 pi divided by time period and linear speed is equal to radius into angular speed. So first we will be discussing our first subtopic, that is angular distance. Angular distance is usually measured when an object is moving in a circular track. So for that we must draw a circle first, and that has a center just drawn, and this is an object which will be traveling in a circular track. So for example, this is a circular track, and here the body will be moving from one position to the another position. So here you can see that the body has changed its position from one place to the another place. So here we can say that the distance from the center of the circle from any point of a circle will be named as radius. And here we all know that body has moved a certain position on a circular track. So here the reference angle from the center of the circle will be changed here, just like this. Here you can see that when the position of a circle changes on the circular track, it will also change the central angle of that particular circle, and that is called angle. And that change in angle, or that angle subtended by a body when it is moving on a circular track, are named as angular distance. So here the angular distance was defined quite precisely, where we can say that angle subtended by a moving object in a circular motion is called angular distance, and this angular distance can be measured in radians. So here 1 radian would be equal to 2 pi, and that approximate value will be 1.51, and it will go so on. So here now we must discuss linear distance. And what is this? When a body is moving on a circular track, you can see that in this diagram that body is moved on a circular track. When you observe the direction of motion on a circular track, that would be representing by a blue line, and this blue line is representing as the curve or the arc on which the body has changed its initial position from one point to the another point, and that change on a circular or a circular track in the form of curve or in the form of arc, or in other words you can say that when an object is changing its position when it is on the curved line or a straight line, named as linear distance, and this linear distance can be measured in meters. So here we are up to discuss relation between the angular distance and the linear distance. So here the angular distance and linear distance can be discussed by using one equation that we had discussed in our mathematics O level, where we found that this type of motion can be defined by using S is equal to R theta. So here the S is representing us the linear distance, R is representing us the radius of the circle, and theta will be representing us that angle, or in other term we can say it as angular distance. So here the linear distance is equal to radius times of angular distance. So with the help of this equation we would be able to define some other physical quantities and relation with them. Now we will be discussing angular speed. What is angular speed? Angular speed is the rate of change in angular displacement. Here, for example, you can see that the body has changed its position on a circular track, and when we take the ratio by time with the change in angular distance, that would be named as angular speed. So here the angular speed can be measured in radian per second, and that would be calculated by using theta divided by time period, and that theta can be replaced by 2 pi. Now what will be discussing our last topic of this video, and that is linear speed. After that we will be learning the relation between the linear speed and the angular speed. Here now linear speed will get simplified to you that this is the rate of change in linear distance would be named as linear speed. So here we can say the definition as the rate of change in linear distance is called linear speed. We all know that the term rate means the ratio by time, and that linear speed can be measured in meters per second. And now we are going to discuss last topic, that is relation between the angular speed and the linear speed. Here we will be seeing that how we will be able to define the relation between angular speed and the linear speed. So we will be using the same equation that we had used for mentioning linear distance and the angular distance relation. So here we will be using this equation, that is S is equal to R theta, that is representing us linear speed is equal to radius times angular distance. Now divide time on the both side of the equation. So here we will be seeing that S divided by T is equal to R theta divided by T. So here S divided by T will be equal to the linear speed of an object, and theta divided by T will be named as angular speed. So here that S divided by T is equal to linear speed, that is represented by using a small v, and the angular speed, that is equal to theta divided by t, that was represented by omega or w like symbol. So here we can define the angular speed and the linear speeds relation by that linear speed is equal to the radius times of angular speed. Thank you for watching me. Don't forget to subscribe my channel to watch new videos.